In this video, we're going to be covering tree diagrams, conditional probability, and complementary probability. Okay, let's go to number 4. The diagram below shows the probabilities for events A and B, with the probability of not A being P. Okay, so for first part A, write down the value of P. So immediately we notice there's two branches of some event. So the chances of A happening is 1/5. What would the chances of not A happening be? So let's say you're rolling a spinner, or spinning a spinner, and the chances of you getting a 1 are 25%. The chances of you not getting that 1 would be 75% chance. We have to subtract it from the whole. So the chances of you not getting A would be 4/5. 1 minus 1/5. Okay, so we have P is equal to 4/5. Now for the probability of B. So we notice that there's actually two ways to get to B. Through A and through not A. So we have to add both of these routes. So for the first route, going through A, it's going to be 1/5 times 1/4, because A and B, you have to multiply them, plus, now for the second route, going through here, it's going to be plus 4/5 times 3/8. Okay, and that's going to be 1/20 plus 12/40, which is 6/20. And this leads to 7/20 is P of B, probability of B. Okay, and now for the probability of not A given B. We have to use the conditional probability formula. Let's substitute our variables. So we're going to have that. The probability of not A given B is equal to not A and B divided by the probability of B. Okay, so we know probability of B is already 7/20, so we can put that in. And now for the probability of and B. So for not A and B, that would mean following this path. So following that path would mean 4/5 times 3/8. So 4/5 times 3/8 is going to be 12/40, and all that divided by 7/20, which is times 20/7. And that's 6/7. Since you're allowed a calculator on the test, you can use that for this problem. Okay, now for number 5. Dumisani is a student at Ivy World College. The probability that he will be woken by his alarm clock is 7/8. If he is woken by his alarm clock, the probability he will be late for school is 1/4. If he is not woken by his alarm clock, the probability that he will be late for school is 3/5. Let W be the event that Dumisani is woken by his alarm clock, and let L be the event that Dumisani is late for school. Okay, so we know right off the bat, the probability of him being woken is 7/8, because here, W. 7/8, we could put that in for chance of W. Now for the probability of not W, that's 1 minus that, the complement, so 1/8 here. Okay, let's keep going. If he is woken by his alarm clock, the probability he'll be late for school is 1/4. That's W and L. That corresponds to this one here. There's the W and the L. So we put 1/4. So that means that the chance of that not happening would be 3/4. Okay, so next piece of information. If he is not woken by his alarm clock, not W. The probability he will be late for school is 3/5. So late, and this is 3/5. Okay. And we can fill that into here. Okay. And then this would mean that this is 2/5. Okay, and the chart is done. Calculate the probability that Dumisani will be late for school. Once again, we said there's actually two ways going through this path and through this path. Two ways for him to be late to school. We have to add both of these ways. Okay, so for the first way, 7/8 times 1/4. Now for the second way. This is the first way, now time for the second one. Plus 1/8 times 3/5. Okay, so 7/32 plus 3/40. Let's use a calculator for this. 7/32 plus 7/40. Sorry, 3/40. Okay, and that's 47/160. And that's the probability he will be late for school. Equal to, okay, now for part C. Given that Dumisani is late for school, let's write this in conditional probability notation. Okay, so given he's late for school, so given L, what's the probability that he was awoken? So awoken given late. Okay, once again, we can use conditional probability. This formula. So we're going to have, this is equal to probability of W and L divided by the probability of just being late. And the probability of being late, we already found that out. That's 47/160. And the numerator is W and L. So let's go back to our tree diagram and follow WL. Okay, so WL is this path, which is going to be 7/8 times 1/4. 7/8 times 1/4. Okay, and we're going to have 7/32 all divided by 47/160. For this, to save time, we can use a calculator again. 7/32 divided by 7/160. Okay, 35/47. That's going to be our answer. This is equal to 35/47. Okay, now for number 7. A bag contains 10 red balls, 10 green balls, and 6 white balls. 2 balls are drawn at random from the bag without replacement. What is the probability that they are of different colors? Okay, for this problem, I would use complementary probability, meaning instead of finding the probability that they're of different colors, first let's find the probability that they're of the same colors and just subtract that from 1. So this is going to be our plan. 1 minus the probability of same colors. And we can break down the probability of same colors into 3 different cases. The probability of getting 2 red balls, one of getting 2 green balls, and the one of getting 2 white balls. Then we could just add these. Okay, so the probability of getting 2 red balls. So for our first pick, we're going to have 10/26. So there's 10 red balls to start with. Then since without replacement, we're not putting them back, we're going to have 9 balls left divided by a total of 25. And since for the green balls, we also start with 10, we use the same logic. 10 over 26 times 9 over 25. And now for the white balls, there's going to be 6 white balls to choose from over a total of 26. And then once you choose that one white ball, we're going to have 5 and 25. Okay, so P of S is going to be the sum of all these products. And we're going to subtract that from 1. Let's put that into the calculator. So we're going to have 1 minus 10, 10 over 26 times 9 over 25, 10 over 26, 10 over 25, 6 over 26 times 5 over 25. Okay, and we're going to have our answer 44 over 65.